Okay, question number 7. Researchers are examining the amount of disruption to forests around the world due to human activity. Two characteristics being examined are the basal area of the dominant tree species and the number of tree species. So similar to question 6. Two possible models are considered for predicting the number of tree species based on the basal area of the dominant tree. So, for Model A, least squared regression line is determined by doing the log of the basal area compared to log of number of tree species. So remember, this is our x, and this is our y hat. Okay. For Model B, the least squared regression line is determined for the basal area. So just using that basal area as our x compared to the log of the tree species. So that's our y hat there. Okay. Computer output of the and a residual plot are shown for each model. So they give us our linear equation. Well, not our linear, but our modified linear equation and our residual plots. So which model is more appropriate? So we're going to look at our residual plots and determine which one looks more random. Okay. And they're both fairly random. They're not too bad, but the best one, would be Model B in terms of its residual plot. There's also something else that we can look at to determine which one is more appropriate, and that is our R squared value. So 0.706 for Model A and 0.798. So this is the better model. So for two reasons, it's going to be Model B. So the first reason is the R squared, not R squared, R squared value is closer to 1 in Model B. Also, the residual plot for Model B has more random scatter. So even though Model A doesn't really have much of a curved pattern or anything like that, there's just more randomness in the residual plot for B. Okay, so since we are using Model B, we need to write the equation for the least squared. So our constant is here, so we're going to write it as 388, and then our slope is here, so minus 0.118. Now remember what our x's and y's are for this. So basal area is our x, and log number of trees is y hat. So parentheses next to our slope, we're going to put basal area. And for the y, it's going to be log number of species hat. Okay. Using our chosen model, predict the number of tree species in the forest with a basal area of 7.4. So we're going to plug in 7.4 into our basal area and calculate the number of species. So I'll just rewrite this. Log number of species hat equals 2.388 minus 0.118 times 7.4. So plug in. So we'll go ahead and plug in the right side of that equation into our calculator. So 2.388 minus 0.118 times 7.4, and that gives us 1.5148. But this is not the number of species. This is equal to the log of the number of species. Now remember, log has a base of 10. So if we raise both these as a power, with a base of 10, those are going to cancel out. Base 10 to the log number of species, that cancels out. So we have number of species equal to 10 to the power of 1.548. And we will throw that into our calculator. 10 to the power of, just hit second and answer. And we get about 32.719 approximately. Oops. Species of trees. And that is it.